Uh, Hello guys. So today we will discuss the Riemann integral question that came in paper 2 of UPSC this year. So the question is easy if you have already seen the theorem, and it might be a moderate if you have not seen the question. Okay. The question was, given f is a monotonic function in a closed interval a to b, then you have to prove that f is Riemann integrable. F is Riemann integrable. Let's see the solution. Okay. So what is the meaning of monotonic? Monotonic means it can be either increasing or it can be decreasing. Okay. So let's us assume f is monotonically increasing function. Okay, the method will be same for decreasing also. Let's prove for one, and we can write similarly for the second increasing function. Okay, this is without loss of generality, which means that you are just generalizing it. Okay, so for this we know that fb will be greater than equal to f of a for all x belonging to ab, that because it is strictly increasing function, so the value will increase as the x increases, so fb will be greater than equal to, so therefore fb minus fa will be greater than equal to 0. So let's take an fb minus fa. Here you can take any k plus k, okay, is greater than equal to k, where k is greater than 0. Okay, so I will use this. Okay, now how to prove something is Riemann integrable? Okay, what is the, so for Riemann integration, for f2 be Riemann integrable, UPF minus, okay, LPF, that is the upper and lower integrals, should be less than epsilon for some partition P. Okay, where P is your partition, right? Okay, so we will use this thing. Okay, we will use this thing to prove our theorem. Okay, so let us consider, okay, consider some d, which is less than epsilon upon fb minus fa plus k. Okay, so I considered this will be very useful later. Okay, now take a partition. Okay, choose partition P, okay, in x0, x1, xn, such that the norm of partition, okay, the norm of partition is less than d. Okay, less than, what is the norm of partition? There's a difference between this, that is x1 minus x0 is less than d. Okay, now mod of UPF minus LPF, which is equals to sigma, okay, supremum of f minus infimum of x f into delta xi, that is your, this will be equal to norm. Okay, so because it is an increasing function, supremum will always be on the low, okay, will always be on the higher side, and infimum will be on lower side. Okay, so this will be f of xi minus f of x of I minus 1 into, this will be delta of xi, okay, your norm, Now we know that norm is less than D. So you can write it as, you can take D common here. Sigma fxi minus f of xi minus 1. Okay. Less than D, if you write it like this, so it will be f of x1 minus x0. X0 is A only, fa, plus f of x2 minus f of x1. Likewise, it will go and go, and then in the end you will get f of b minus f of x and minus 1, because f of, so all these will cancel out. Okay, everything will cancel out. Okay, this is fx2. This will also cancel out. This will also cancel out. So you will get less than D into f of b minus f of a. What was D? Okay, what was D? D was epsilon upon fb minus f plus k. Okay, so let's write the value of D. So this will be less than epsilon fb minus fa upon fb minus fa plus k. So if you see, this value is less than 1, right? This less than 1. So there, this will be less than epsilon. It means that UPF minus LPF is less than epsilon. Okay, less than epsilon. So if it is less than epsilon, what does it mean? That therefore F is integrable. F is integrable. So the whole trick in this question was choosing the norm in such a way that in the end we can prove that it is less than epsilon. So I chose the norm as norm which is less than, okay, which is less than epsilon upon fb minus fa plus k. Okay, so this was if the function of increasing. Okay, function is increasing. Similarly, okay, similarly, okay, we can prove for f is decreasing. How will you prove for f is decreasing? Nothing will change, only your norm will change. Here, instead of f of b minus f of a, you will take f of a minus f of b. Rest everything will remain same, and you don't need to prove both sides. That's a 10 marker question. Just write the line. Similarly, we can prove for f is decreasing also. This implies every monotonic function in a closed interval is monotonic, is Riemann integrable. Okay, Riemann integrable. So this was a little tricky question. If you're not seen it might not be easy to do in the exam. Okay. Oh, okay. Have a good day.